Okay, the first thing I'd like to announce is that I already released homework 3 right before I came here. I then realized I only uploaded to session 1. So after class, I will upload to session 2 and session 3 as well. So please take a look, start to think about it. So let me tell you my plan. My plan is today I will finish everything in chapter 12. And then on Wednesday in the lecture, I will actually doing some demo and go into some detail about homework assignment number 3. So what is homework assignment number 3? Just in a nutshell, is that so the power of object-oriented language is really about modeling some real-world event. So essentially what we have is a bunch of description. You can see that this is actually what happened last Wednesday when the instructor from this location carry my phone and maybe my device, actually go to the silo station. And then I encounter another student on the bus, their interaction about some of the homework assignments. It's a very simple scenario. I mean, we can make this a lot more complicated, which if the information is necessary. So your challenge is to using the concept of class and object and try to provide the model. I mean, you should define whatever you like, but you can actually think about the concept of person and thing. Pretty much if you have a person and thing, and then you have location, you have time, you can think about, you can actually already model a lot of stuff. So homework assignment number 3 is what I call a stage 1. So I will explain to you what the stage 1. And then we have a stage 2. In fact, stage 2, we will ask some of the group after they submit, some other group is going to review your design, your implementation, and they actually compare their own. And then they said why they think yours is better or theirs is better and why you think you can improve. And then you actually will get your feedback from stage 2. Okay, so that's the first one is just stage 1. Stage 1 should be fairly straightforward. I mean, just how do you actually model a person, when and where he was, and location and things like that. So there is a few record that you need to produce using this paradigm. And also one of the things which I'm going to introduce for homework assignment number 3 is a concept of the JSON class. So JSON is a very powerful representation of the data that's actually, you can actually use it in C++. And therefore, we will ask you to write a function called dump to JSON for every single class you actually implement. And that will be explained in detail and the demonstration with the reference code and given to you on Wednesday. Okay, so just let you know, this is going to happen on Wednesday. Well, the next thing I'm going to continue is overloading. I'm going to finish today with overloading as well as some of the issue about the 3 constructor in C++, which is default constructor, copy constructor, and move constructor. And also will show you that how to use them with some example. And that's my instructional plan today. So last week, we didn't do much about, last Friday. It's basically, we went to this example. We had some good discussion, like a warm-up about what is operator overloading. And it's just, as I point out is really make the code maybe in some cases is more readable, looks prettier in some sense. So it's comparing these two code, they're actually essentially doing the same thing. But one of the code, which is more naturally for some of the experienced programmer to actually say, oh, box 1 greater than box 2. And instead of trying to understand box 1, compare their volume and then try to do box 2. Okay, so this is two different paradigm. It's syntactically and semantically, they're doing exactly the same thing. However, it's just the readability, and somehow, sometimes with this abstraction, the concept called overloading the operator, which in this case is overloading the operator greater than. This actually might cause confusion as we show people some example. So I just want to, before we introduce any further, just want to repeat the important thing is that it's really operator overloading for the whole thing that cover in chapter 12 mainly. It's really for readability. Make sure when you actually have a team, two people are actually writing the code, you're going to use that. And for example, in homework 4, you're going to actually review somebody else's code. And therefore, how do you make sure your code readability is really, really good? And that is for you to consider when appropriately use the operator overloading. All right, so let's actually look at how it's done. So I'm showing the example about operator greater than. So the way to now the top part is the part that you're going to write the code in order to do that. So you have to say bool operator greater than, and then basically using the implementation. That's an example because you actually define the method within the class definition, which is actually, personally, I'm actually against that. So I'm going to show you the code that we did. I forgot whether I show you. I think I showed very quickly to you about person.h. In the person.h, there is, I actually define an operator overloading, operator equal. So basically I overload another operator, which is, okay, that's interesting. Second. Cannot hear my mic, right? What? I cannot put it. Oh, you know what? Sorry, I have to untwist it. I'm an engineer, and I try to make things to work. Okay, that sounds good. Okay, so in this example, I didn't include the implementation of the operator equal in the definition, a class definition. So what I had was in person.cpp. Inside person.cpp, if you look at here, is essentially the what we call operator equal. And then the way to do it in the separate compilation is you have to use a class name person and to call column, and then operator equal. And I actually remember that we went through this as the last exercise, that because in this example, what do we mean to compare two person? So this has to be really clear. The semantics has to be really clear to the application programmer who want to use this particular member function. Okay, so this has to be communicated very clearly. Otherwise, you don't know what is the operator equal on person object. Is this the social security number or is just the name? Okay, or the combination of both. Okay, so this is the way to really implement this particular one. Okay. Okay, so just let you know that it's kind of interesting in the operator overloading. This is the common way for you to actually be able to let two objects to be able to work together. It's just one object. The operator overloading help us to be able to work with operator involve multiple objects. And therefore, the paradigm really is you, for example, you have two boxes. One is the box this, but there's another box which is a box or another box. So essentially, the paradigm is that in the implementation, you kind of need to bring the other object, the second object, into the internal of the first object. And then in the context of the first object, you did that comparison as we see the implementation. Okay. So the next slide, just for your information, usually we don't do so many of this. Essentially, you can overload pretty much every single operator in the language. So that includes not just greater than and smaller than, equal, and then also the logical operation, the plus minus, all this arithmetics. And also, for example, you can actually overloading things like bracket as well. You can overload bracket, you can overload any kind of operator. So when do we use bracket? In C or C++, when do we use bracket? Array, yes, we overload. Array is actually is an operator. You can actually overload the meaning of the array as well. Okay, we'll show you some example that way. Okay, so you have a bunch of things that you can overload the semantic, except a few things you cannot overload. And this is essentially, for example, anything to do with a class definition, for example, you cannot overload, or anything to do with like a size of or dot or star, this kind of pointer or content operator, those you cannot overload. But pretty much everything else you can overload, except those things put in there. Okay. Okay, so I'm going to show you something which is, I already talked about this, so I'm going to skip this part. But I want to show you one thing, which is, this is a little bit controversial about C++. So in C++, we talk about the concept called encapsulation, meaning that providing interface is the only information you need for the people to use the object you define. The rest you can link to that. But operator overloading essentially break the principle of encapsulation in some case if you need to see the source code of the operator overloading implementation. This is nothing, how do I say that? It is in practice that sometimes if you don't have to reveal the source code and people won't confused about the semantics about your function implementation, then don't worry about that. That's fine. You can still maintain encapsulation. But the thing is that if you actually try to reveal the source code, like all the internal, then in principle, you actually break the principle of encapsulation in C++. So why I mention this? Because a lot of design principle about how you can, for example, homework 3, you're going to decide, what kind of object you're going to provide, what kind of interface you're going to provide. So the thing is that if when you design those things, always keep in mind the principle of encapsulation, because you want to protect the detailed implementation-oriented information in the black box. But the people just need to know the definition, need to know the interface. They won't be able to use your class without any trouble. Okay, so that's something just want to remind you. Okay, so now I want to tell you this, is that operator overloading, in fact, you can actually find how it's defined. It's actually defined as a concept called template. We haven't talked about template. I think template is in chapter 16 or chapter 18, something like that. And we will cover template, about how do you do template in general. And for example, like how do you write a lambda expression? How do you do a template? How do you actually do a template class? But operator overloading, you already can find its code under, in my computer, sorry, because the bar just covered that. It's actually, this is in my computer. If you have a MacBook, there is a library developer command line tools / user include / C++ v1 / utility. In my computer, is actually in the under that directory. But in every single computer you have, regardless, this is the MacBook or it's a Windows system, WSL, you should be able to find that file called utility. Within that, let me just actually show you where it is, at least on my computer. I hope this is still there. Let's try to, should have a check before I come to this class today. No such file, great, okay. So this is probably in my older computer. Let me see if it's there. Okay, I have it here, USR, include, C++, V1. What? Doesn't have it? So when I developed the slide, that was on my Intel-based Mac, but right now I have a different Mac. This is embarrassed. It's gone, actually. -L. No, it's gone. Okay, let me actually do a very quick thing. Find slash, I will do this, sudo while I'm giving more lecture. Find slash minus name utility minus print. Okay. Okay, so if you want to find some, oh, okay, I think I found something. Okay, I think I found it. Okay, it's actually right now is under a different directory. So just a coaching moment that I really use when I want to find my file in a Unix environment, using the find command, FIND, really useful. Just say man find, you will see all the stuff there. So I believe this is the file. This version of operating system, they probably move it to a different place. Okay, so this is the libcpp. You can see over here, there's a lot of template. And let's actually look for the template. You see here, everything is operator overloading. Operator, there is a template, and with the class I'm using, and it basically correspond to the in my slide. Let me bring my slide back. Corresponding to this part of the code I just showed you. Okay, so it's in that file. You should use a find command depending on what computer you're using. You should be able to look at the utility And sometimes look at the include file about how they implement this piece of code, really help you to understand the detail about the programming language itself. All right, so now you won't be feeling kind of puzzled about how this is actually being done. Okay, right. So that's where you can find all the operator overloading is being handled. So now I want to give you something, another thing which is interesting. I'm going to skip this part. No, I don't want to do this. So I'm actually particularly look at 6 operator overloading. That this 6 operator overloading is called relational operator. This 6. This is basically the most commonly used operator overloading. So in order to use this, you have to include utility as the file I just show you where to find it. But in programmer, you don't need to worry about the whole pass. Okay, the system, the compiler should already figure out where on your computer they're going to look for this kind of system include file. So you just need to say include utility, and then that will be good enough for you to use this 6 operator. Okay. So I'm actually going to compare 2 pieces of program to you. This is a bit tricky, but I want you to actually take a look. So I have 2 class person. They're almost identical. I want you to look at what's the difference between left and right. Okay, just hold on 1 second. I just want to tell you that before this code, I have utility, I have use namespace, std, relops. This 2 line must include that for you to use operator overloading. Okay, so what's the difference between these 2? Yeah. Okay, so one of them, each of them has actually only 2 operator overloading. One is actually with equal and with a smaller sign, smaller than, and then the other one is equal and greater than, right? Okay, so assuming you define those two relational operators. Is that significant? So now I'm actually going to write the code looks like this. I'm actually writing the piece of code like that after you define the person object, like the previous slide. So I'm going to run this piece of code. This piece of code, you can see that I use all 6 relational operator. I use all 6 of them. Okay, my question to you is that which piece of code in the previous slide will compile successfully? So you see that the question is tricky because I only define 2 of them. I only define 2 of them. And then I'm actually using all 6 of them. Then I'm asking you, which one actually will work. The other one will work because the compiler is going to give you error. I'm going to show you. So normally, let me ask you as a programmer, how should you determine which one will compile, which one will not? Oh, well, we have 2 ways to do it. Okay, the first way is just to ask ChatGPT. Okay, hey ChatGPT, which one will work, right? But the other piece which you can actually do is you just bring this 2 pieces of code in your computer, just run both of them to see if both of them will work or neither of them will work, right? Just that's our mentality. So let me actually tell you the answer is that the left side will work, the right side will not. The left side, and then you haven't run your program, just guess why. The left side, this one, the purple one is okay, but the red one actually will give you compiler error looks like this. Let me show you the compiler error looks like this. If you try to do this, you will actually get this error. Okay, they basically say, hey, you didn't define the small. Remember, I write the program, I want to do all 6 of them, and it says, no, the smaller than is actually not right. You'll realize that that's actually very strange. You see that they're actually trying to go through a bunch of include file in the same directory C++ version 1, okay? So actually, let me tell you that the logic is this, is that in the design of operator overloading, especially for a relational operator, you actually don't need to define all 6 of them. You just need to define 2 of them. And then the compiler will be able to figure out the other 4. But unfortunately, the compiler is not so smart that is actually forcing you to define specific 2 of them. Essentially, you need to define equal and the smaller than. If you actually define equal, then the compiler knows how to actually generate not equal. Okay, if you know equal, I can generate not equal. If you actually give me smaller than, then I can actually do greater than and equal, right? Just negation. You apply negation to your code as the result. Then essentially with equal and greater than, I actually have 4 of them already. Then you have smaller than and equal with this 2, then you can basically generate the other 4. So essentially, it's nothing tricky, nothing magic, is that as a programmer in using operator overloading, using the relation operator, you basically just define 2 of them, and then the rest, the compiler will generate. But those 2 must be equal and smaller than. And you cannot do this way. You see now why I said this code is bad, because you have operator equal and greater than. No, the compiler says you must have defined equal and the smaller than. Those 2 you must define, and the other 4 they will generate for you. Okay, so just let you know, if you want to use the utility and the std : rel ops, that's what you need to do. Yeah.
So if you define double equals, do you have to define smaller than?
Well, if you only define equal, you can only use equal.
Okay.
But if you define both equal and smaller than, you can use all 6 of them.
Okay. What is now? So you can't only define greater than.
You cannot. You cannot, because the template won't work that way.
Okay, but you define greater than and less than to do different things.
You can, but then you don't use the utility. Don't use their template. If you don't include a utility template, then essentially you can do whatever you want.
As long as I don't use less than, I can define greater than.
Okay, I take it back. I took it back. Sorry. When you say you want to do your own thing about greater than, right? They are assuming your greater than is the opposite of smaller than or smaller than equal. Okay, so they are assuming, so they will be using whatever code you provide. But when you say you want to define your own thing, that means your greater than and your smaller than and equal is not exactly logically complement to each other, right? That's what you're saying. Okay, number 1, I never done that. As a programmer, I have to write the program to do that. My best guess is that don't use utility. You just basically define like operator. Yeah, okay. That's a great question, actually. I think I like that question because it basically challenge. You can take a look at the utility to see how they actually do it. But if you don't include it, you just include the part you want to include, and then you modify the rest. Okay. But make sure your teammate understand what you're doing. That's most important. That's the power of the language. The power of the language is in your hand. All right, any other question? Okay, so I think I'm done with this part. Now I'm going to finish the chapter 12 with the three constructor that this is in your textbook from page 374 to 380. So in C++, there are three kind of constructor. One is called default constructor, one is called copy constructor, one's called move constructor. Of course, you have another one called default destructor. You can actually delete things when you want to do that. Okay, so first, first let's actually talk about constructor destructor. Then I will talk about there are two different ways for you to create a new object or to delete an object. Okay, there are two different ways to do that. One is just a normal way to do it, which I already showed you a few examples. And the other one is almost like a malloc and free style of operation. So you probably heard about malloc and free is a dynamic way for you to allocate memory for your structure, for your array, for your objects as well. Okay, so that's the second way. I'm going to first not touch on that, but first focus on this three constructor, which is purple, green, and blue. So let's actually first look at how do you actually differentiate the way to define whether that constructor is a default constructor or a copy constructor or move constructor. Okay, so essentially, a default constructor means that this constructor does not take any argument. So it's essentially, if you don't do anything, it's just basically create a blank object and give it to you. Okay, it's just create object without guarantee about the initialization, about the value. That's actually called default constructor. And the default constructor, you don't have to declare it. If you don't have anything, the default constructor and the copy constructor usually is implicitly already included. Okay, and the thing is that the default constructor, if you want to really define it explicitly, then you basically is like assuming this class is called data, and then just basically put a pair of parentheses without anything, and that's the default constructor. Okay, now I want to look at what I call the copy constructor and the move constructor. So the copy constructor is essentially I want to clone another object. So you have another object I want to clone. For example, I want to clone a GPS location. I want to clone a person. So essentially, I take another object as the input data that into the constructor call of the current object. So in this case, you can see that I'm actually copy everything from the other object called another data. I call a data. Okay, usually I say a something means another. All right, so you basically look at the parameter because you're a copy, so you shouldn't change anything about the object. So you put a const, means that you're not supposed to change this object. And over here, you pass in the reference to that particular object. So that's why you have a 1 sign, and then that's represent a call by reference, and the green part represent I'm doing the copy. Okay, move constructor is very interesting. Move constructor essentially is not clone. It's actually I want to take an object, and essentially that object must occupy some memory. So essentially, I want to create an object that's actually using the other object's memory. So essentially, I move that content without doing the copy. And I just use that. And the original object will be gone after the move constructor because it actually moved to this object now. So that is, to be honest with you, unless you're doing something like a very performance sensitive, usually we don't need to do move constructor. So the move constructor the major benefit is really safe copying in terms of initialization. For example, you have a huge database. I want to actually move to a different object. Maybe this object maybe have an inheritance, so it actually have a more stuff than the original object. But I want to make a copy, and therefore I use a move constructor to actually move the whole thing, the memory space, into this new object I just create, and then I can, from there, I can actually add more stuff into that. Okay, so that's the idea of move constructor. And it is, I would say, if you're not doing this kind of very, very performance critical, especially about memory usage, you probably don't need to use move constructor. But we still, occasionally people use move constructor to do certain things. So for example, in the move constructor, you actually define, because now you're going to move the whole thing, you need to have access. So no longer you don't have constant, you don't have const. And then what you have is that, okay, you have data instead of one M sign, now you actually have a 2M sign. That's the move constructor. How do you actually specify that is a move constructor? Okay, that's how you do that. Okay, I'm going to show you some example about how. So let me just summarize what we did. Is that you probably know default constructor doing essentially nothing. Copy constructor is clone, and move constructor just try to move the memory from one object to the other without try to avoid any kind of copy. Okay. Okay, I'm going to write a piece of code before I actually come back to this new and delete business. Where is my code? Here. Okay, so here I actually define a class I call data string. In this code, I probably have two versions. One is actually related to the data is a string, but the other way is as an integer. So this one is the same as the data, but it has the string value inside. So you can see that this is my class. It's a very simple class. Very simple class. And this class, everything is public. And I didn't define any interface, but the default copy move constructor is implicitly included. If you don't say anything, it will be there. Okay. And okay, now I'm actually going to tell you what I look at the program. Let's actually do this part. I want you to actually talk to your neighbor about this. So just look at this few piece of code. First, make sure you understand this piece of code here. This first section of code, I actually define an object A following this definition data string, and I set the value of the string to be the string 111. And then I print the value 111. And then I actually create another object B, but this time I'm actually have some constructor. Can somebody tell me what is this? Is this the default constructor, copy, or move constructor? It's a copy constructor. That's right. Good. Okay. So I make the copy constructor. After I make a copy, I actually change the value to 222. And I print the value A and B. Okay, just this section of code. What do you think it will be the printout for this line? For this line, what should be the printout for this line? It's going to be 111. By the way, this is the way we do printf in C++. Is using cout. Okay, instead of using format string, you're doing like this. Okay. This is the way C++ you use a string, which I haven't actually go over the detail, but I will touch on that. Okay, so this one is going to be 111. Okay, good. Let me actually write down your answer. You said this is going to be print out 111. How about this one? 111 again, right? This is 111. Good. You're getting it. How about this one? 222, because you overwrite, right? All right, all right. So now I'm actually going to do this part. It's a little bit tricky. What's this constructor? This is the move constructor. All right. So I basically moved the A to C. And then before I actually move, I just want to tell you, remind you, this is actually printing 111, right? Okay, so now I'm actually going to do this. I'm going to print A, B, and C. After I do the move constructor to C, right? I basically create an object data stream C using move constructor A. And I'm actually going to do those three. What do you think will be the first value? You're right. It's nothing. It's unguaranteed, by the way. It's unguaranteed. On my computer, it's actually printed out nothing. I will show you how it works. But how about B? This will be 222. Great. So I try on my Mac, but I also try Linux. I think it's the same behavior, but you can actually try your computer. And how about this one? C. It's going to be 111. Okay, good. You guys are doing good. Let me see. That's very strange. Why did I do this? If you copy constructor, a constructor already moved. Let's actually see how it works. I forgot this one, okay? I feel this one is kind of, okay, this one, I don't know, but let's actually, this one, if I print C, should be still 111. And I print A, this should be question. Okay, that's my prediction. Let's actually look at the result before I look at the last 3 lines of code. Okay, the nice thing about Emacs, which I can actually run this code while I'm actually looking at the code itself. Okay, so let's actually take a look at each of the line, how it produced the code. I'm going to do G++ minus std equal to C plus 14. And then I'm going to use data string dot cpp and then minus O, I will call it, well, I'll call it spring 2023. Okay, so wow, it took a while for this small piece of code to compile. Let's actually take a look at the output. Okay, let's actually look at the output. The first part, remember, the first part is 111. Okay, so we check. This one is 111. Check. And the second one is 111, so we check. And the third one is 222, we check. Okay, so far so good. And this one is checked. All right, so the first 4 are good. But then you see that you actually see a blank line there. That means it's nothing. There's no string, it's a null string. It's nothing. But null is really strange because I actually cannot tell whether it's really null string or it's actually some random value is undisplayable. So this one check. It doesn't have anything. Okay. And then you have 222, which is here. 222. Okay, now we know that. And then 111 check. Okay, great. And then after this, you see you have another one, which is actually null. And then you have a 111. And then finally, after this 111 is another null. Okay, it's another null. Okay, so now I hope I convince you, at least on my computer, that this is the program that's will produce the result based on the impact about which constructor you're using, which type of constructor, default, copy, or the move constructor. Okay, now I'm actually going to show you a different way of creating object. It's almost like a malloc and free. So essentially, we're saying is malloc in C++, this is correspond to new. And then free is actually correspond to delete. Okay, so the difference is that in C, when you do malloc, the language system only provide you some amount of memory that you specify. But when you new, it will actually not only give you the amount of memory you need, it also invoke the one of the constructor. Okay, by default, if you don't say anything, it's going to be default constructor. But if you say something, it's actually going to give you different. So let's take a look at this. I actually create an object. Now you see that I create a new object, data string, but just like a malloc, it's a pointer. I actually define a pointer of e_ptr is a pointer to a data string object. So I actually declare e_ptr as a pointer. And then I say new. Remember, new is equal to malloc. So new, I said data string. But in the data string, you see what I did is it's a copy constructor, right? I'm using a copy constructor. Essentially, I create an object, make a copy of B, and then basically I want to get the another clone, and then have the ePTR, which is the pointer pointing to that new object. Okay, and the thing is that after you have that, just like what you did with a pointer, you can just say ePTR point to the value because it's a pointer, or you can say star ePTR, which you dereference that pointer and say dot value. Those two should give you exactly the same thing. That's why if you go, can you give me back my shell? You see that right now, everything is 222, okay? It's basically just like that. It's just a different way to, sorry, I have to move down a little bit. So this is just a different way of using constructor. So, okay, let me summarize what I told you today. Number one, what is operator overloading? Number one. Number two, what is relation operator overloading? If you want to use a utility, I think your idea is great that you don't have to use that to use operator overloading that way. Number three, you know 3 different constructor. Similarly, you actually have also constructor that only one type. In constructor, you don't have the 3 different types. It's just a default constructor. Number 4, I want you to remember there's 2 different ways of create object. One is just create object like what we did here. Like this, I just basically say the class name, say the object. So A is an object. But the second way to create object is using the command new. And I have to basically declare a pointer, and then I use a new to do that. Okay, any question? Yes. Oh, good question. When we malloc, using malloc, what's the negative consequence if we forgot to free? We basically have a memory leak. The same thing, if you actually create an object not using new, you actually don't need to do delete. But if you use new, that's a malloc. Then you have to do delete. It's just save memory, okay? Which is important. That's an excellent question. I like that a lot. For the programmer, you have to remember whenever you use new, you always have to correspond where to delete them. Otherwise, your memory might be in trouble. Okay, good question. Thank you. Give me
like, if I'm thinking-
one